A turbocharger harnesses a vehicle's exhaust gases to compress air. When that pressurized air is forced into the engine's combustion chamber, engine performance increases. With it, a small engine can be as powerful as a larger one, using energy that would otherwise be lost. The exhaust gas turbocharger dates back over a century, but in recent years, the concept has been picking up speed. Design tweaks and the use of lighter materials mean a bigger boost to engine output, so power can be increased without using so much extra fuel. Production begins at the foundry. A sprayer blows sand into this specially shaped cavity. The spraying action activates a binder applied to the sand. This causes a chemical reaction that solidifies the particles. The worker extracts the hardened sand shape from the box. The shape is called a core. It'll be used to mold the inside of the turbocharger's housing. They file down any bumps or rough edges. They then apply adhesive around the border of a second sand mold and glue the two parts together to build up the core. They apply a putty-like compound to the seam to plug any gaps. Meanwhile, they use a different technique to make smaller cores. They rock the box, which causes sand to flow into a shaped cavity. The sand has been mixed with heat-sensitive chemicals. They aim a flame at an opening in the box as burners warm it from the sides. This process also hardens the sand inside, so it takes the shape of the cavity. The result is another smaller turbocharger core. These sand cores are now ready for casting. They place the cores in a mold, which is also made of hardened sand. The bottom half is fitted to the top half, essentially closing the mold. They pour in molten aluminium, which flows into the spaces between the cores and outer mold. The aluminium takes a minute to solidify, then the molds tumble onto a conveyor, revealing the cast turbocharger parts. They're connected by hardened flow lines. After separating the parts, they go off to the turbocharger factory. Here, computerized tools carve and contour the aluminium part. The specifications are so precise, they're measured in hundredths of a millimeter. This is the turbocharger housing before the work was done, and this is what it looks like after. Using a computerized probe, a technician looks for irregularities. Even tiny ones will need to be fixed. It's now time to assemble all the parts. The worker inserts a bearing into one end of the center housing. He lubricates a second bearing and slots it into the other end. These bearings will support a shaft that has a turbine on one end and a compressor on the other. He adds a metal collar and a third bearing to the assembly. He then caps the bearing parts with a metal plate to prevent the lubricant from spilling out when the turbocharger spins. Next, he installs a metal heat shield on the bottom of the housing. He inserts the shaft and turbine wheel assembly. Then he installs the compressor wheel on the other end of the shaft. He heats the wheel briefly, causing it to expand. This allows it to be pushed further down the shaft. Once cooled, it contracts to the shaft for a tight fit. Next, a machine called a vibration sort rig spins the compressor at high speed as a computer analyzes it for vibrations. The slightest tremor indicates an imbalance. The computer also detects the source of the problem, so it can be fixed. He grinds the compressor nose ever so slightly to balance the part. He now fits the compressor into the curled aluminium housing. The shape is designed to funnel air into the engine. He secures the compressor with a metal ring. He fits the turbine end into its housing. This also has that distinctive curl to pipe the exhaust gases in the right direction and increase pressure. A blast of air now simulates the effect of those exhaust gases, spinning the turbine to power the compressor. It takes about 15 minutes to build one of these turbos. Once installed in an engine, it's full speed ahead.